Today I worked on a small project where I mocked up a proof of concept for an application. I decided I would use parts that I just had sitting around, which kind of got me in trouble. Fortunately, I was able to fix my mistake with one of these. What is it? Well, I'll show you. It was right about at this moment that I realized that I kind of screwed up. You see, the fiber optic amplifier has two NPN outputs, and the multicolored indicating light requires two PNP inputs. So the fiber optic amplifier is supplying 0 volts, and the indicating light is looking for plus voltage. So how did I solve it? Well, you'll see here in a second. So this little product right here is the RCM-1 signal converter. So as you can see, the fiber optic amplifier supplies 0 volt DC to the load, NPN output. The multicolored indicating light needs a PNP input, so it definitely isn't going to work. But not to worry, we have a signal converter, the RCM-1X3, that'll do up to 3 NPN to 3 PNP. Now if you are confused by any of that, I went ahead and drew up a quick example explaining NPN outputs. The bottom line is that the sensor is switching the negative side of the load and supplying 0 volts to the indicating light, shown here in the example. And the multicolored input light requires PNP inputs, meaning that you need to give it a plus voltage on the wire that tells it what color to choose. So in this example, one side of the indicating light is tied to 0 volts, and the black input wire that the sensor would be tied to is got to receive 24 volts DC positive. Here's a simple wiring diagram of the RCM module. It'll accept up to 3 NPN inputs and converts them to 3 PNP output signals. The next little drawing here shows how the fiber optic amplifier with the 2 NPN outputs will be tied to the indicating lights. If you get confused, just pause the screen and take a look at it, but it should make sense to you knowing that the PNP output is now giving you a plus 24 volts into the indicating light. With that problem solved, I can get back to my build. As for the application, basically I had 2 different parts that had holes drilled into them, each with a slightly different diameter. So I ended up using the wide beam array made by Optex FA, the NF-TS40 fiber array, and the D3RF multi-output fiber optic amplifier D3RF TDN. After attaching the fiber array into the amplifier, I set up the sensor so that output 1 is activated when the part with the smaller diameter hole is present within the 40mm beam. The output turns on the green LED, and output 2 is activated when the part with the larger diameter hole is present within the beam. The output turns on the red LED. I will put links in the description for the converter modules that we offer, as well as for the sensors used in this project. Please remember to like the video and subscribe if you haven't already. If you have any questions, please call us at 800-280-6933 or send me an email at nsales@ramcoi.com. Thanks a lot.